Do you have a retaining wall that you want to take off its quantities? At Engineer Tina Academy, you'll get the solution to that problem. Welcome guys back again to my YouTube channel. My name is Christine, and if you are new here, you know how we do it. Kindly subscribe, share, and don't forget to leave a comment. Now, on today's tutorial, we are going to look at how to take off quantities of a retaining wall. Where this question has been asked many times by most of you, and we are so grateful that today we've been able to find time and do that retaining wall. So it's very helpful. This tutorial is going to be very helpful for students who are preparing for their examination, and also for those of us who are in the industry and need to take off the quantities of our retaining wall. So guys, today I just want us to look at this retaining wall that we have, so that we can be able to know how the quantities are done. So stay with us as we go through the retaining wall. First of all, let's study the retaining wall and know what it consists and what we need before we proceed to the items that we need to measure. Now, this here is our retaining wall. This is our retaining wall. This is the section through a retaining wall, and then we have the plan. Now, if you look at the retaining wall, what we have down here is the width of the foundation concrete, which is 1:3:6, and then the depth of the foundation concrete is 600. This one here is 600. And then this is our retaining wall. It is trapezoidal in shape. And then the bottom width of the retaining wall is 450, the top, sorry, and then the bottom is 150. The depth of the retaining wall is that 500 plus 400. And then on this other side, we have piers. You find that these piers can be made of stones. The piers here at 400 millimeter center to center, you find that these piers can be made of stones, concrete, and the reason for the piers is to help reinforce the retaining wall, so that the retaining wall can be able to hold the pressure that comes from the soil. So that is the reason of the piers. So these piers here are behind the retaining wall. And then this one, the retaining wall is made of reinforced concrete with a ratio of 1:2:4. And then we have a 100 millimeter weephole at 2 meters center to center. And this weephole is used to drain water actually from the soil. That is the purpose of the weephole. And then we have at this far end of the weephole, we have the continuous pocket of ballast between the piers. So each weephole has a continuous pocket. So if we look at, we've been told the wall is 10 meters long. Our wall is 10 meters long. And then if we look at the plan here, this is now, this is our piers here. This is our piers. This is the top. This is, sorry, no, yes. So this is the wall, and then this is the thickness, and then these are our piers here. So this is the depth. This is the, yes, this is the, not the depth, this is the pier down here. In plan, this is our pier down here. So let's proceed and see how we are going to take off those quantities. So number one, items that we are going to measure, we are going to do excavation. Excavation, because look at where we have the ground level here. At this point is where we have the ground level, but we need, from this point, we need to get this excavation so that we can be able to lay our mass concrete and our retaining wall. And then we are going to do the mass concrete in foundation concrete here, in the retaining wall, and in the piers here. And then we are going to place concrete in what we use civil engineering standard method of measurement. You find that we take off quantities of placing. Now this is concrete, and there's that act of placing the concrete. And then we have the concrete auxiliaries, that is formwork to fair finish. Fair finish is this surface that you see here. And then formwork to rough finish. Rough finish is the surface that you cannot see. And then we have the inserts. So guys, without wasting a lot of time, let's proceed to taking off those quantities. Make sure you stay with us, stay with me here until the end so that we can be able to learn together. Remember, we are open for comments, so feel free to comment and we'll get back to you as soon as possible. Now let's start with excavation. So this is our ground level here. That is our ground level. From the ground level up to the bottom of the foundation concrete, we need a depth of 400 plus 600. So the width of our excavation will be from this point up to this point, that is at 500. And then the length, remember we've been told the wall is 10 meters. So we are going to take the length, the width, and the depth. So we say excavate pits to save retaining walls with a depth of 1.0 meters. We proceed to mass concrete. So we need this concrete here in the concrete in the foundation, concrete in the retaining wall, and concrete in the piers. Now let's start with the concrete in the foundation. So in the foundation, our width is that 500. This one here is our width. The depth is 600, and then our wall is 10 meters long. So we take the length, that is 10.0, the width 3.5, and then the depth 0.60, and then we say 1:3 concrete in 20 millimeters aggregate in the foundation. We go to the walls, concrete in the walls. So our wall, the length is 10 meters. Yeah, now we are here. Yeah, we are here. So the wall is 10 meters. The depth is from this point. Yeah, is from this point up to this point. That is where we have our depth. So it's the 500 plus 400. That gives us 3,900 millimeters. Good. Now our width will be the top width and the bottom width, and then we find the average. So our top width is 450, the bottom is 150, then we divide by that gives us 975 millimeters. So we book that volume, we have 10.00, the depth, the width is 0.98, and then the depth is 3.90. Then we say 1:2 concrete in 20 millimeters aggregate in the walls. So we go to the piers. Now these are our piers. These one are our piers. So the piers are spaced at 400 millimeters center to center. So it means on our 10 meters long wall, we have piers that are spaced at 400 millimeters. Sorry guys, let's take this one to be 4,000, because when we calculate when we proceed to another aspect, we're going to find that the number of piers that we get cannot be able to fit in the walls. So we make that correction and we take this one to be 4,000 millimeters center to center. So let's get the number of piers. We are going to take the entire length, then divide by spacing plus 1. So our length is 10,000, the spacing is 4,000. We divide by that and then we add 1, we get 4 numbers. So we are having 4. This one, and then another one, like that, like that, like that, until 4 of them on the 10 meters long wall. Now our length of the pier is our length of the pier from the plan is 750. Yes, because we have the length. If that is the pier, we have the length. We can illustrate it here a bit. If that is the pier, we have the length, and then we have the width, and then yeah. So that is our pier like that. So we have 700, 700 and 450. Yes, so that is our fire going down like this. So you find that the height of the fire, the height of this fire is the same as the height of the wall. So the fire and the wall, they share the same height. Now the length is 700. Yeah, so I've drawn it on the other side, but at least you can understand that we have one side, this is the length, this is the width. I've drawn it as taking this one to be our width. So the other side is our length, that is 700. And then the height, say the height of the fire is the same as the height of the wall, that is that 500 plus 400, that gives us that 900. And remember we have four of them, so we book that the length 0.70, 0.45, and then we have 0.9054. One is for concrete in 20 millimeters aggregate in the fires. Good. We go to placing. Now that is what I was saying. In placing, this is the act. Now we take off act of pouring. You know, after you prepare the concrete, after the mixing, you support it to the place that you want to place, and then you do the placing, the pouring concrete in the formwork. That is the placing. So we want to look at the outtake of the quantities of placing in mass foundation. Now, mass foundation. Now, when we are taking the placing in the civil engineering standard measurement, placing is done in intervals of 500 millimeters. So we are going to take the thickness, and then we are going to state whether it exceeds 500 millimeters or whether it does not exceed 500 millimeters. Now, and the ones we have at 500 by 600. So then the length is 10 meters long. So our placing quantities will be 10.0 by 3.5, and then by 0.6, and then we say mass concrete in foundation exceeding 500. Of course, our thickness is 600, which exceeds 500. Now let's look at the walls. The walls now, we want to place concrete in these walls. So we are going to take the depth where the thickness is 500. For the walls, we are taking the thickness 500, and then the other one will book in there, we'll book it separate. So we book them separate. Now, what do I mean? I mean, if this is for 50, let me just try and draw that one. Or we can just illustrate here. So this one is for 50. And then it means if I draw a line here, sorry, the line is not straight. So what I was saying, if I draw a line here, like that, and then I cut it there, this one is 450. This is what we have here. Transfer is here. What we have at the top, I've transferred here. And then because we need a thickness of 500, this one becomes 50 to make the entire width to be 500. Now what we are going to do, we are going to take the average. For us to get this, we are going to take the average, that is 400 plus 500 divided by 2. That gives us 475. Now we are going to find the height. We are going to find the height x here. That is from this top up to where we have the width of 500. We are going to find that height. Now we are going to find this height using similar triangles. Now, if we want to extract this triangle, this one, we want to extract it. So if we extract it, we'll have we have a triangle like that, and then I'm just expecting this triangle here. So this one becomes 50, and on the bottom we had from this point up to this point is 1500. We subtract 450, so this becomes 1050, and then the height of the bigger triangle is from here up to here, that is at 900, and then the small one is x. So we are going to use similar triangle formula. So we take this at 9, the bigger triangle as height is at 9, and our width is 15. So it's going to be 3.9 divided by 1.05, which is equivalent to the width of the bigger triangle. That is, sorry, we are taking 3.9 divided by 3.9 divided by x. The length, the height of the bigger triangle divided by the height of the smaller triangle, equivalent to the width of the length of the small triangle, which is 0.05, divided by the length of the width of the small triangle, which is 0.05. So if you calculate that one, you're going to find your x to be 0.19. So that is how you find the small x. So that becomes our height. So we are going to book that one first. So we have 10.00 by the width is 0.48, and then the height is 0.19, and then we say mass concrete for wall thickness 300 to 500 millimeters piers. Yes, and then we are going to book. Sorry, let's book for the. So this one is for the wall. This is for the walls. So when we are booking mass placing of mass concrete, we do it with their piers. You book the wall at 500. At this point, we are going to book this placing of this concrete in this wall, and then with their accompanied with their piers. So their piers are going to have the same height, that is 0.19, and then the width, the length was 700, the width was 450. So what inches is there is height, and then they were 4. So we book them, and then we say mass concrete for wall thickness 300 to 500 and their piers. Now let's proceed to what remains. So what remains is from this point here up to this point. We can call it y. So y will be that 900, that is the entire height, that is that 900, and then we subtract what was here, that is 0.19. That gives us the 8.8 meters. And then the width is going to be the width at the top here, and then divide by the width at the bottom, and then we find the average. So that is 0. The top is 0.15, and then divide by 2, that gives us 0. So we have the height, we have the width, the wall length is 10 meters. So for the piers, they will also take the same. The length remains the same, that is 700. The width of the pier is 450, and then the height is going to be the height of the wall. And that is like pier. So we go for that one. The 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 width is 1.0, and then the height is 8.8. And then for the piers, it's the same. The length is 700, that is 0.00, and then the width is 0.45, and then the height is 38.880. So that is 0. Then there are 4. And then we say mass concrete for walls exceeding 500 millimeters and their piers. Well, guys, we are somewhere. So let's go to concrete auxiliaries. So this one is where we include the formwork that is going to hold the. So for this process, we are going to start with the fair finish. Now, if this is our remover, 1.6, Yeah. So this service here that you see here, now if we expect that one, I want us to find the I want us to find the hypotenuse of that finish. Yes. So we have this one is like 900. Yeah. And then this one is 450. And then this one is 1500. The pile of it. And then this X is going to be 20. That is 1500 minus. Now we want to find y here. So y will be the square root of 3.9 squared plus 1.0 squared. 2.40 meters. So we need to book that fair finish. This one is formwork to the fair finish here. Now we book that one. So we are going to have the length that is 10 meters long, and then the hypotenuse, which was 4.04, and then we say swan timber formwork to the fair finish. Now let's look at the rough finish, how the rough finish looks like. So we are going to deduct the length for the rough finish is at the back. You see, we place concrete here. This is where we have the rough finish here at the back. So we need to find the length covered by the fires, because fires are already holding the concrete. So at where we have fires, because remember, for the 10 meters long, we have wall. This is our back of the retaining wall. We have fires. At here we have a fire of 700. Then at another spacing we have a fire 700, continuous like that up to the entire 10 meters. So we want to get this space that is already covered by the fires. So the fire had a length of 700, and then they were 4 in number, so meaning they have covered 20 meters of the 10-meter wall. So for this 10-meter wall, we have 2.8 that is covered by the fires. Because where we have the fires, we don't need formwork to hold the concrete, because we construct the fires first before, and then we construct the wall. So the fires comes before we do the retaining concrete wall. So the fires, at this point, the fires are acting as our formwork. Now, once we subtract that, here that what it means is 2.72 meters. Now, we need these 2 points. Yeah, we need, that is 7.2 meters. That is what it means. So that will be our length, and then the height still remains. That is from the top up to the bottom. That is 3.90. So same formwork to the wall. And then let's look at the formwork, the piers. So these piers, they need formwork. Yes, because we are doing the piers first. So they need formwork, hold the piers. So we are going to look at the vertical, that is for 700 by 300. So it will be 0.7 by 3.0, and then by 4. Then we say vertical to the formwork to the vertical sides of the piers. Now, these piers, they have the sides. They are like that. So this, they have sides, which is 450 by the length, that is 3.9. And then, yes, so we are going to book formwork to, formwork to the side. So the sides are to this side and the other side. Yes, because the vertical is one, because this side, the back is on the wall, so we only have one vertical side. So this one we are going to say the big is 0.45 by 3.9, and then by 4, and by 2, and then we say formwork to the sides of the piers. So we are moving on well. Now let's go to the inserts. So the inserts is the weephole that we have and the continuous pocket of sand between the piers. Now the weepholes are at 200 millimeters center to center. So meaning at on the back here at our length of 100 at a distance of 2000 millimeters or 2 meters at our length of 10 meters, sorry, and at a distance of 2 meters we have the weepholes that are used to drain the water. So we need to find the number. So the number will be 10 meters divided by spacing of 2 meters plus that gives us 6. Then we are just going to put it in numbers. So we say 1 by 6 and then we say 100 millimeter clay where laid drain fixed on rake. Yeah, so that is the weephole. Remember we said the purpose of the weephole is to drain, just to drain the water. And then we have the pocket, this pipe, this one is the pocket. So the pocket goes hand in hand with the weaves, and then we say a person continuous pocket ballast between the piers. So guys, thank you very much for your time. We come to the end of the retaining wall. It is so simple, it's so understanding.